Hello and welcome to this next webinar in our webathon series. I'm Dr. Steve Gandy. I'm going to talk about how an integrated life cycle approach to overall risk and process safety will help us improve our operational performance. So we know that process safety is all about the ability to reduce the prospect of having releases, whether they're hydrocarbon releases that could lead to fires or explosions, or whether they're toxic releases. And we know that the equipment that we use to help us with reducing the likelihood, the risk of this occurring is very important. And normally this would be some form of control system, basic process control system, and possibly a safety instrumented system as well. And therefore, when it comes to the safety instrumented system, we need to make sure that it is going to be properly designed, installed, etc., and maintained to help us ensure we can reduce the risk of any serious accidents occurring. And of course, the equipment under control will be very carefully selected and implemented to do this job. And this is where functional safety comes in, because it applies to the equipment under control and in particular the safety instrumented system. So part of that as well is with the control system and the safety instrumented system, we may also be relying on humans. So for example, alarms. If the control system is generating alarms and we're relying on the human to interact with the machine and to be able to identify the alarm and take the appropriate action, and of course have the time to take the appropriate action to bring the process back into a safe state. So that's also an integral part of overall process safety. And of course we know very well now the problems with cybersecurity instances where we can have malware being introduced into the control systems and the safety systems that can effectively bypass them and allow an attacker to manipulate the process to cause some unstable and potentially dangerous situation. So those three, the functional safety, the alarm management, and the cybersecurity are all an integral part of that. And this is where it comes into play with taking an integrated process risk maturity model approach. If we do it right, then of course what we end up doing is we improve the overall safety for our people, but more importantly, we will reduce the prospect of having any downtime, any outages, because we know statistically that during startup and maintenance, those are when they're the highest possible hazardous situations will occur, and where statistically most of the accidents occur. So if we can reduce that, we can reduce the need to restart, and of course that means that it reduces the overall cost. So this is how we can benefit from implementing a maturity model approach, a risk maturity model approach. And this means that we take a more pragmatic approach to this, to balance it, to make sure that we can improve our operational processes, and we can obviously benefit from the fact that yes, we'll get some short-term gains, but in the longer term we will have a much more balanced approach. And this is where the three, the functional safety, the alarm management, and the cybersecurity, have a lot of commonality, because all three of them have a life cycle. It's not a once and done, and all three of them have the same phases. There's an analysis phase, there's a design and implementation, and then there's an operation and maintenance phase. So these three phases have similar requirements across the three disciplines, the functional safety, the cybersecurity, and the alarm management. And what we've been able to do is work with clients to help them implement this type of approach and help them create a roadmap, if you like, in how to achieve the most pragmatic implementation. So what binds all of these together? Well, if you think of it this way, and I've sort of touched on that by saying, what is the consequence of inaction? If the alarms aren't properly managed, if we haven't properly rationalized the alarms so that we know what the priorities are, we know what the operators need to do to deal with those priorities, and they have the time to do that. If the alarms haven't been rationalized, then under process upset conditions, you can end up in an alarm flood situation, where now the operators are being bombarded with all sorts of alarms. They can't see the wood for the trees, and by the time they've figured it all out, it's probably too late. So having well rationalized alarms is important, so that we know that when an alarm occurs, we know the priority of that alarm, the operator understands what he needs or she needs to do to address that alarm, and they have the time to do it. Then there's the consequences of failure on demand. So for example, if we were relying on the operators but they weren't able to respond in time, now we've gone from the basic process control system not being able to respond to relying on the safety instrumented system. So therefore, there will be a consequence of a failure on demand. So we need to make sure that the safety instrumented system and its safety instrumented functions are properly well maintained so that they will not fail on demand, or the likelihood of them failing, the probability of them failing on demand is very low. And then of course we've got the consequence of compromise. As I said, cybersecurity and malware is a real thing these days, and we have to be mindful of that. It won't necessarily be an external attack coming in. It could be somebody's inadvertently introduced some malware without knowing it. And if that happens, and depending upon the type of malware and the severity, if we don't have the proper cybersecurity defenses in place, then it's quite possible that the basic process control system and the safety instrumented system could be compromised. In which case now we have a very serious situation if we have no control and no automatic safety protection layer. So these three very much into play. And you can see that, as we've shown here in the diagram, there's also the equipment, because the equipment under control is very important. So the choice and selection of equipment, especially when it comes to the safety instrumented system, is very important. And then people, the people aspect, making sure that our people are properly trained and competent to be able to carry out the life cycle tasks required for the three disciplines. All of this plays together. And what governs all of this, of course, is the overall company culture. Culture comes from the top, it has to permeate down, and of course, if the culture is one of, we've got to keep everything to a minimum, do the bare minimum, we're not going to spend time, effort or money, we're not going to train our people properly. So of course, that has a significant impact on the people trying to implement and do things right. So from the cultural point of view, and I talked about this in the previous webinar on functional safety management, that having the right process safety culture is very important. So management needs to understand and support all of this, otherwise we're not going to be able to achieve the level of protection that we, number one, we intended to have, and number two, we need. So they have to buy in to support the three life cycles. And as I said, it's not once and done. They have specific phases of the life cycle. And the other thing is that we want to develop an open and learning culture. It's very important that we encourage the employees, if they see anything that's wrong, if they see any gaps, they should not be afraid to highlight that, and they should be able to raise this to the appropriate level in terms of the management level to get the right attention. So doing things right and doing the right things should be the mantra. This is what we want to get to. So this means that we have to make sure that our operation and maintenance people are properly trained and there are written procedures that are being followed. There have been many accidents or cases where the accidents occurred because procedures were not being followed. In some cases they were being violated, so they were completely ignored. So it's very important that if we have procedures that they are being followed. The use of metrics and documentation is very important. And that's because the modern standards that we use for functional safety, cybersecurity and alarm management are more performance-based rather than prescriptive. In the old days, a lot of the standards were prescriptive. So what's the difference? The difference is with a prescriptive standard, it says this is what you have to do and this is how you do it. There's no leeway. But with a performance-based standard, it says this is what you have to do, but then again, how you do it is entirely up to you. So again, that allows us to use advances in technology, allows us to use best practice and so forth. But the only stipulation is that we need to be able to measure our performance to be able to prove that we're achieving the targets we set for ourselves in the first place. So that means we obviously have to have metrics in place, we have to be able to measure, and we have to be able to compare to what we originally thought. So if it's done right, it will actually save time and money. As I mentioned earlier, the Lifecycle approach allows us to balance. Because, okay, at the front end we might be spending a bit more, but this will be recovered at the back end because we're having less downtime, we're having less issues, we're having less problems, if you like, failures, and so forth. All of which has a cost impact because we have to, especially with failures, we may have to start up again. And then, depending upon the process, that could be hazardous and it can be potentially quite lengthy. So we want to make sure that we minimize the amount of downtime. As I said, it is a long-term investment, but we can still get some short-term gains. If we look at the three again, we can see the different standards that apply. So for example, for the alarm, the international standard is the 62682. Here in the US, it's the ISA 182 is predominantly the standard that's followed. For the cybersecurity, it's the IEC 62443, which again is a performance-based standard. And for the process side of things, the process industries, it comes under the IEC 61511, which is also performance-based. For the device selection, IEC 61508 for SIL requirements for certified devices, and again 62443 for cybersecurity certified devices. And a lot more companies now are having their products certified to the 62443 requirements. And then on top of that is the certification of people. You could be a certified functional safety expert, a certified cyber automation controls engineer, for example. And then you've got what we call PMP. You've got the policies and procedures and the tools. So all those points that intercede there where the touch points are, this is where tools and policies and procedures can be very beneficial. As I mentioned, all three life cycles have the same three phases. We have an analysis phase, we have a design and implementation, and we have an operation and maintenance phase. And interestingly, from the functional safety point of view, with the change made to IEC 61511 in 2016, they added in a clause for cybersecurity, which is 8.2.4, which requires us to do a risk assessment on the safety instrumented system. So this is something that we need to do now. And that of course ties in with the requirements for, and the standard points us towards following the 62443. In fact, there's an ISA technical report group committee, the TR8409, and they came up with an approach that's very similar to the safety, in that we have a cyber security management system, we have a cyber security management plan for how we're going to implement cyber security, and we do cyber security assessments and cyber security audits in the same way as we would do for safety. So this is the same approach. It's just recommended that we follow that. So that ties us in with, again, the functional safety side of things. And for the alarm management, the same thing. We still need to define what the requirements are. We need to create a master alarm database. That means we need some form of alarm philosophy that we want to follow, and then we use that to rationalize the alarms. And there's an ongoing process where we will periodically go back and do audits and make sure if any alarms are added, is the master alarm database up to date or not? So these three have the same three life cycles. And what you'll see to the left side are the management and administrative controls. So the management and administrative controls covers the whole of the three phases. And I like to keep things simple, so I characterize this as, if you like, the glue that holds it all together. And of course, if we don't follow our management controls and administration procedures, etc., then what happens is we very quickly become unstuck. And that's when problems can occur. So from the safety lifecycle point of view, the objective here was to help us minimize creating some of the problems that we've had in the past, to help us balance our risk with our design, to optimize that, and obviously to help us eliminate any weaker link designs. The two things we need to be concerned about are avoiding systematic faults as far as possible, and helping to reduce the random faults. So random faults typically, I say typically, apply to the hardware, the equipment, but people can also make random mistakes. A lot of times people think that these two requirements are mutually exclusive, but they're not, because even though people can be well trained, competent, experienced, all of that, they can still make mistakes. So these are the two things that we worry about. So when it comes to the systematic, the reason we worry about this is the famous HSE, Health and Safety Executive Study, that was done in the UK. First and foremost, it was done back in '95 and repeated again in 2003. And this is where they looked at accidents involving control and safety systems. And what they concluded was 44% of the accidents were due to the fact that the design specification was bad. So that's a fairly significant percentage that's down to bad specification. A further 15% was implementation. Well, of course, if the design's bad to start with, the specification's bad, the implementation isn't going to be much better. But also, after installation and commissioning, and during operation and maintenance, there's also another 35% there. So this is very important to understand, because these are all systematic in nature. They're systematic failures in nature. The sad part about this was they redid the study in 2003, some 8 years later, and the percentages hadn't really changed that much. So we need to be very mindful of systematic. And here's the reason why. Dear old Trevor Kletz, who's sadly no longer with us, he's known as the grandfather of safety. He used to say, if you think safety is expensive, try an accident, because accidents can cost a lot of money, not just in terms of the financial losses initially, but for the company's long-term reputation. So it's very important, and you can go down and you can look at some of these numbers. And in fact, the Transocean, the BP Deepwater Horizon, the last time I looked, the estimates were more than $60 billion just for one accident. And you can go down the list and you can see that a lot of this is avoidable, especially when it comes to the Chinese incident. Here they actually had jail terms, but worst case, the chairman actually received a death sentence. Now whether it was carried out or not, I don't know, but they received a death sentence in the extreme. And all of these, when you look at them, come down to one simple fact, that there was a poor safety culture. And as I said, culture has to come from the top, has to be top-down driven, and if that's not there, then it's very difficult to be able to implement any of those life cycle requirements effectively, let alone trying to do all three. So this is a sobering thought, and it's something that we should consider, because when it comes to the systematic, we need to follow our either functional safety management, alarm management, or our cybersecurity management. Because what we're trying to do is we're trying to manage those systematic failures to a low enough or acceptable enough level that it's not going to cause us major problems. And this means that we have to look at our life cycle activities, make sure we've defined responsibilities, roles and responsibilities, and making sure that the people are competent. This is what we call the 3 Ps. And to manage the risk of the systematic faults, we have to manage the 3 Ps. The first one being the people, the competency aspect. Another major change in the 2016 edition of 1511 was the emphasis on personnel competency and having well-defined roles and responsibilities. So making sure our people are trained and competent to carry out the tasks for which they're been assigned. And this means that we also have to do periodic, standard uses the term periodic assessments on the personnel. So first P, people. Are they properly trained, qualified and competent to do the work? The second one, procedures. Do we have written procedures that are being followed? So this is where a breakdown in administrative controls and not tracking to make sure that procedures are being followed can lead us to have potential incidents which could be very expensive. And the third P is the paperwork. Do we have a paper trail to prove that we're doing what we said we were going to do? So this was another major change in the standard. Also, as part of the change in 2016, we are now required to do what's known as a functional safety assessment number 4, which is a periodic, again, after an operation in time, we do a review. Remember, it's a performance-based standard. So if we're not going to measure performance, how do we know if we're meeting our targets or not? So we're now required to do a performance assessment. So that means we have to be gathering field data, identifying the key performance indicators that we want to track, and then being able to go back and measure against that. So this is where this process maturity approach comes into play. Because again, we're trying to reduce the risk to an acceptable level to meet the company standards and to meet the regulatory requirements as well. So we've defined 5 levels of maturity of a company. At the lowest level, of what we call milestone 0, at this level, companies here really don't see doing any of this as any benefit. They see it more or less as a tax, and companies at this level have basically never had any problems up to this point. And I've had discussions with companies where that's been the response. Well, we've never had a problem before, why should we worry about it now? But the way I explain it is, if you think of it in these terms, for every second of every minute, of every hour, of every day, of every week, of every month, of every year, your risk is going up and up and up and up. And eventually, you may run out of luck. So companies down at milestone 0, this is a very tough sell. because they don't see the benefit in it. They don't see that they can, they just see it as being a cost which they don't need. When it comes to ML1, this is what we call the triage stage, because here usually companies at this level have experienced some form of incident. And now there's been a recognition of, oh, we've got to do something. We need to get on and do something. So there's a beginning that there can be some benefits to be gained from taking this approach of looking at following at least one life cycle to start with. And normally they'll then reach out for help with certain pain points. When we get to milestone 2 now, this is where there's some corporate compliance. So the culture is progressing to the point where now the management understand and needs to comply. And so therefore it's a top-down implementation. Typically there's some core group that's assigned, and more or less they will be focusing on one life cycle, usually the safety life cycle, to start with. So you can see what we're ending up doing, going left to right. We're going from doing things right to actually doing the right things. And when you get to level 3 now, the milestone 3, this is more, there's a recognition, we've got into this, we're comfortable with doing it, there's now more of a multifunction engagement, and we start to look at not just one life cycle, we're looking at another life cycle, whether that's cybersecurity, for example. And most companies should really try and get to the ML3 stage to really start seeing the benefits. When you get to milestone 4 now, well, this is where everything is done according to evidence. So we've done all the gathering, we've done the analysis, we've improved our planning and scheduling, and everything's done based on data. So there are very few companies that can truly say they're at ML4. So these are the steps in the maturity cycle. So the functional safety assessment that I mentioned, the FSA 4, which is highlighted here, the standard 1511 standard, and also if you follow the equivalent in the cyber, there are 5 functional safety assessments that we need to do from the safety point of view. And depending upon how you interpret the standard, the mandatory ones are 3 and 4. So for stage 4, in order for us to progress from ML2 to ML3 to ML4, we've got to start being more tuned into gathering our performance data and doing the analysis. So the level 4 now is a requirement under the 1511 standard. So how does this relate to industry incidences, for example? What do they have in common? Well, typically the incidents occur during the operation and maintenance phase. As I've said, normally the most hazardous and risky part of the overall process is during startup or during maintenance. That's when most of the accidents have occurred. Then secondly, the majority of these incidents occur within the developed countries, where we have much older facilities. So what we need to be able to do is an investigation based on evidence, of course, to judge whether or not the functional safety has been achieved and that the SIS, the safety instrumented system, and the other protection layers are actually doing their job. And also it helps us identify any potential issues or gaps so that we can address them before any accidents occur, especially if they're systematic by nature. What we've found, of course, is that not all the findings are the same. So we've worked with many different clients over a number of years across different parts of the world. And what we found is the number of FSA findings per site has not resulted in a dramatic reduction of issues and problems. And I suppose one way you could look at this is if you paint your kitchen, for example, then of course the rest of the house looks like it needs to be done as well. So what we're trying to do is we're trying to remove the major risk and then move further towards a different paradigm, a paradigm shift. So going more towards using the evidence that we're gathering to help us with crafting our longer term solution. So for example, with the Functional Safety Assessment 4, the period of time is not defined, but we could use the 5-year revalidation window between doing our hazard and risk assessments, because 5 years should be a reasonable amount of time to gather field data, to do some proof testing, for example, to gather information on our cybersecurity and gather information on our alarms, for example, and our operational procedures, and then use that information to feed into the next revalidation. So that could be a reasonable window. Of course, if we're having incidences and problems, we don't want to wait 5 years to do that. We would probably want to do an analysis fairly quickly. So what we're trying to do is optimize removal of lower level risk, so we can not worry about that. So when it comes to the findings, you can see here that we looked at over a 5-year period. We looked at different sites, and we can see that we've managed to see a reduction in major findings, and then of course there's an increase in the minor ones. It is important that if you're going to be doing these studies that you learn from that and you look for improvement. So it's an ongoing improvement process, and we all know that there's always room for improvement. So this is where doing these studies will help us, and understanding how it relates to the organizational maturity in terms of the three, whether it's functional safety, cybersecurity, alarm management, or all three, depending upon where you are and how you're viewing those life cycles. So why aren't they the same? Well, of course, you might have new work processes being introduced, which will help us increase compliance, but we might find that we've now got legacy shortfalls, for example. A lot of old legacy systems have issues and problems that we might not be looking at or addressing. So this is another way of being able to identify if we do have some issues. Revalidation activities can create a mismatch of information across the life cycles, depending upon when you do it and whether or not it's consistent. And of course, it takes us time to do that. So especially if we've got different facilities, different performance levels at different facilities, they can have different maturity at the different facilities and so on. Also, access to the right people and the data is another issue. And there might not be any previous FSAs with any early life cycle reviews. And unfortunately that's true, because a lot of the times when I talk to companies and ask, have you done an FSA 1 or an FSA 2? They haven't done it. Some companies now are beginning to understand the benefits of doing this, because of course the purpose of a functional safety assessment is to help us find potential problems in that particular phase of the life cycle, especially systematic ones. So if we're not doing them, then we could be saving up a bunch of problems for later on when we have to do our mandatory FSA 3 before starting up. And of course, if we find problems there, that can delay startup and cause all sorts of other problems. So previous FSA are important to do, and then the actions that are coming out of that are not necessarily managed if they have done them. And of course, you find that you've got gaps appearing in compliance. I started this by saying it's a pragmatic approach. So again, from our perspective, when we talk about pragmatic, is the first thing we want to understand is what is the client's goal? What are you trying to achieve? And then we craft the solution to meet their particular requirement. Some of the issues, for example, relying on quantity of actions is not a true indication of whether or not you've achieved any functional safety. So most of the time, again, stakeholders and regulators don't necessarily have a true understanding on the current level of maturity of the organization. And in fact, even in the organization, I had a very interesting discussion with a company where I had management in the room, I had engineering, I had operations, maintenance, and I put up the slide with the 5 maturity levels, and after explaining what they were, I said to the group, okay, where do you think you are? And management immediately said, oh, we're at level 3. And when the rest of them had stopped laughing, they said, no, we're lucky if we're at between level 1 and level 2. And then they proceeded to have an argument over the differences. So a lot of the times, even within the organization itself, there's a difference of opinion in terms of what maturity level. And then understanding how we can improve and how we can learn from sites that are doing well and sites that are not doing so well. And then understanding how does this compare to our peers. So the best way to do that and have a repeatable method to do that is to use tools. So for example, we create what we call a safety case tool, which looks at the compliance arguments. Okay, do we meet this particular requirement, yes or no? And what are the arguments for and against? And then using the audit tool. So being able to go in and do a specific audit to find or to look for the metrics and the data we need to support the fact that we're meeting our performance level, and also to give us an indication of our maturity. So there are 10 areas that we focus on. The first is the management planning. Remember I said that management and planning covers the whole life cycle, and it's the glue that holds it all together. It's how we're going to implement the life cycle. And then of course training and competency comes into play, making sure that our people are properly competent and trained to do the work, looking at the risk evaluation and the risk management, doing all the risk analysis, then the inspection and testing, making sure that the safety instrumented system and its safety instrumented functions are being properly maintained. We're tracking useful life, we're doing the proof testing accordingly, we're following mechanical integrity and so on. The operation and maintenance procedures are in place and being followed. We can see that. And of course the management of any bypassing on the SIS. Again, another change in the 2016 edition of 1511 was to now require a bypass log to be in place and bypassing to be properly authorized, implemented and signed off once it's been removed. Then you've got the performance monitoring and review of the SIS in terms of, did we have any demands, real or otherwise? Have we had any failures and so on? And then the management of change. Did we need to implement any changes? And if so, did we follow management of change requirements as defined in the standard? Assessments, auditing and revisions. Have we done any of those? Have they been done in the past? And of course, documentation control and configuration management. Again, for changes in application, those should come under management of change, and we should have configuration management control in place. So all of those things are looked at as part of this performance review under the stage 4. And just to remind us again about the levels, red through to green, then when we do the report, we issue the certificate, for example, where you can see, using the colors, we can indicate where the maturity is currently, and then you can track that over time every time you do these assessments. We've created this schema that falls under our ANAB accreditation quality management system that we have in place. So we have it documented, we have all the competency requirements in place, and it's a fully audited program. So again, if we follow this approach, you will end up with a consistent result globally. So it doesn't matter whether you've got sites in the US, sites in Europe, Middle East, Far East, you'll get a consistent result. And it could be that the maturity is different in different regions, of course, and then you can track your own corporate growth with each functional safety assessment that we do. So this is the purpose of doing this. The value add to all of this is, of course, you as an operator, your competitiveness can be improved because now you've increased your operational performance. You're monitoring that, you're making sure that you're maximizing your efficiency and your performance. So you've got less downtime, of course, you've got a decrease in operational costs because you're not having expensive failures or incidents that requires reactive spending, for example. You can be more proactive with your maintenance. So again, reduce your reactive spending, improve by being proactive. Gives you a consistent framework for measuring your performance again, and it helps understanding the strengths and weaknesses and where to improve, especially if you have different sites that are performing differently. And it also focuses and leverages the competency and knowledge that currently exists within the organization. And it helps you to build those knowledge, skills and attitudes that support performance. So as you have older people or more seasoned people moving towards retirement, you can bring in the younger next generation and make sure that there's a crossover, there's a handing off of the keys, if you like, so that you don't lose that knowledge and experience and you can build on that. And that's part of your competency development. So if we consider this then, all three life cycles for alarm, cybersecurity and functional safety have the same three phases. There's an analysis phase, design and implementation, and an operation and maintenance. That all three require management systems to be in place to help us manage those life cycles, manage the tasks that we need to perform within those life cycles. And as I always tell the classes, if you're old enough to remember the 20-20-20 adage, it used to be 20 weeks in design, 20 months in implementation, 20 years in operation. So we're going to be spending the majority of our time in that operation and maintenance phase for the overall lifetime of the system. Making sure we have the right culture is very imperative and management needs to understand and support this, otherwise it doesn't work. Implementing an integrated approach to risk management will help us improve our performance. As I've said, if we do the things right, we can end up improving how the site operates, and by being able to identify the key metrics and be able to measure those metrics through doing the functional safety assessment 4 or audits and assessments, that is the name of the game. Making sure people are properly trained and qualified, etc., is very important. The procedures and the overall processes need to be covered by any of these management systems that we have in place, primarily for us to be able to help spot and manage systematic issues. Functional safety assessments and audits are required, of course, to ensure that we are following the processes and procedures that have been defined and help us safeguard against those systematic errors. So again, they're there for a reason, we should use them. And the same is true for cybersecurity and for alarm management. We also need to be doing auditing and making sure that we follow our defined processes and procedures. Competency is the key to all of this, of course, and making sure that we have a well-defined competency development program is very important. We put it all together then. Roles and responsibilities need to be well defined, and people need to be aware of their role so that we don't have misunderstandings and things fall through the gaps, because somebody thinks that somebody else is responsible for this part of the life cycle when they're not. Using tools and checklists is a great way to ensure consistency and help improve the efficiency, of course, and well-trained and competent people are the key to making sure this implementation is effective. Now, I've emphasized that I don't know how many times, but this is very important. Managers need to ensure that any deficiencies or gaps that are highlighted through any of the audits or assessments are remediated as soon as possible, because it's important that we follow through with anything that we spot. Use of independent qualified third parties can obviously help with conducting these audits and help provide the level of independence that we need to show. So I hope you found this interesting, and if you've got any questions, please feel free, let me know. Be happy to answer any questions. And I thank you for listening and look forward to attending a webinar in the future. Thanks very much.